And all right, let me get us started here. And we are, as usual, a few minutes early. And of course, those who are not here at this point can scroll back and see what's going on. Now, want to make certain that we're cued into where we are in the course and where we are this week, etc. So I want to start, first of all, with the textbook. And I'm going to go over here and find our text, the Introduction to Management Science. And all of the work that we're doing this week, we're doing integer linear programming, and we're working with these different applications of that using Solver. Now, you'll see we're here at, I'm over here at page 7, chapter 7. You see I've got a long, okay, Laney, go ahead and see us, Sarah, you as well. Now, I'll close this off. And again, we were going to talk, we've reviewed Foster, I think Gorman, and then we're going to talk about Ice Cold, RMC, and Martin Beck, and then what's going to be happening next week in terms of the class. Now, I'm going to go ahead and let you guys, well, let me start with this. First of all, I have the solution files here for us to look at and to talk about. And I think we had done Ice Cold and I think maybe RMC with and without setup costs. I don't recall that. But again, I want to alert your attention to these capital budgeting basics that are over here. I've got that link, a link that talks about order and setup costs, and then the Northwest Corner method using the solver. And then I gave you kind of an overview here of jobs and logistics and supply chain management and the opportunities that are out there. So I think what I want to do is, again, go back to the RMC case because it's probably a little different than what you might have seen or have expected. And so I'm going to do a quick search, and I'm going to do RMC, and this will give us the text. And but then we'll go, and then we want to go over to page 330. Okay, and there, of course, is the solution in the lingo using the ice cold refrigerator problem. So that's okay. We're good there. Now, again, we're looking at go and no go binary types of problems. I'm either going to do this or activities. I'm either going to do it or I'm not. And this is all within the context in chapter 7 of what we call capital budgeting. And you should understand right now that capital budgeting is when we purchase an asset or develop a program or add a product line, anything that will have implications beyond a 1-year lifespan. Now, we might have a 1-year lifespan. I guess you could typically, well, I guess you could do that and say that it's a capital budgeting exercise, so that would be okay. But I think what's more typical are going to be multi-year types of efforts. Now, here as we look at this this case, and we'll move down here, and it starts over here on 330. Okay, we see the solution and they're trying and the optimal objective value. Okay, and they're trying to get the best combination of setup costs and production that they can do. Now, RMC is what we would call a batch producer. And what we mean by that is this. RMC takes orders from customers and they make batches of product or component or whatever it is that the text says that they do here, okay? And they have a setup cost, and the way they're working with solvents, and they're producing some type of, I guess, a cleaning fluid. But you could see the setup costs, and when you're a batch producer, you have to be aware of setup costs because you literally have to set up the assembly line to make the product. When you're because different products have different requirements, they have different components, they need different tooling and different machining. The assembly line is different. If you're in a batch manufacturer, you have people who are typically cross-trained to work at different posts or jobs within a work node. And so literally when you look at an assembly line, you're looking at a network problem, okay? And with a batch situation like you are with you have to be with RMC, you have to be careful about the setup costs because you've got to spend money to get the line set up. Okay, so they give you the setup costs for each of these products and the maximum production. Okay, and notice that we come to, and I'm over here on page 331, and you'll see the binary aspect of this where we have a 1 and a 0. A 1 is, so it's a binary, it's a go or it's a no-go. This occurs when we are in what we call capital budgeting, and we're dealing with projects, okay? And we're trying to decide which of these will we do, which of these will we not do. Now, within a capital budget project itself, you can have activities that you can choose to do or not to choose. You could have a full-blown project. So even within that capital budgeting project, you can have that type of situation. So, well, we just won't do this piece of it. We'll do the other 3 pieces or whatever. And the technical term for all this, especially when we tried it when we have limited resources, is what we call capital rationing. And a company will have only so much money to do capital projects. If the larger the firm they are, the more likely they are to have a capital budgeting committee who will look at proposals and will decide what one looks the best. Well, we've got RMC, and they've got 2 situations where they're dealing with setup costs, and they provide us this value, the optimal figure, and then we walk down here and we start to see, okay, the capacity constraints, okay, and the fixed cost model, and we're trying to maximize our return or production, and that's with setup costs. Now, they're going to walk us through also without setup costs, okay, and again, that's that binary situation that we're talking about. Now, I want to go over, and if you'll take a look now for a moment at, well, I have 2 files there over in the module, and we're in module 6, okay? And glad to see the rest of you here. Azra, okay, Colton, Laney, Michael, Patty, glad to see you here, Robert, Sarah, Shane, Logan, good. Now, let's look at RMC without the setup costs, and there's the file. Now, you say, upload RMC here. All right, if you want to upload both files, you can do so. If you want to upload one file, you can do so, because I know there are the 2 different files with RMC, okay, with the setup costs and without. Let's look at it first with the setup costs. So I'm gonna download that file. All right, and I'm gonna stick it over here in my folder. I'll throw this down, and I'll put the RMC with setup costs. And let's take a look at it. We'll open it up. Okay, and I'll move this out of the way. All right, and let's take a look at it. Now, this is with setup costs, and here are the materials requirements. Now, again, as I've said over and over and over, a good worksheet is going to have the following items, and we'll just start with that. It's going to have the it's going to have a title or some type of ID and what it's supposed to do. Then we're going to see an assumptions area, okay, and here's the assumptions area right here. Okay, then we're going to see some output measure and computational area, and we're trying to maximize our net profit. Okay, so to handle each of these materials, we're going to do it with the setup costs. Now, if you have, there's, and I spoke some about the what we call the batch manufacturer. There's also what we call a long run continuous manufacturer. And probably the supreme example of that would be a utility company in which the lights, the electricity is running all the time. The water is water systems running all the time. That's a continuous system, and it has to be monitored and worked with. And you can, of course, have shutdowns, or you can have disruptions. But that's literally, and PG&E makes electricity, which they literally do, or they convey it to us. That's a continuous process. Now, there are some what we call hybrid situations, in which you have a long run continuous product line, maybe that you make, that you're always making and sending out the door, and then maybe specialized batch production. Now, so those are tougher to pin down in the real world, the definitions of them, than they are in actual They are more in actual practice than they are theoretically. Okay, a steel company, for example, the great steel companies of the 20th century, they were, for all intents and purposes, continuous producers. They made steel night and day, and if they didn't sell it, they operated from the lowest possible cost, okay, by using economy of scale. And then if they didn't have anything to sell, they just stored the stuff. Okay. Now we'll look here for just a sec. Now, again, we have this assumptions area, and we have the material requirements by ton. Okay. And then what we've got available. And whoever that is out there, you need to check your microphone, make sure it's muted. Okay. All right. Thank you. Now, we've got the profit per ton, the setup cost, and the capacity. And what we want to see is the net profit, and we want to maximize that. Okay. So we'll look at this for just a second. Let me see who needs to be muted. All right. Okay. Anybody else needs to have their microphone muted? All right. Good enough. Now, away we go. Okay. Now let's go up to Solver and take a look at it. And of course, we'll click on Data. And we're going to go to the Solver. And here it is. There's our objective function. It's over on C17, and we want to maximize our net profit. All right. And then we've chosen that. And then by changing the variables B21 to D22, and let's come over here and take a look at those. And let's find B21 in that array of B21, okay, to D22. And here they are. And this is the tons produced, okay, and the tons produced per product, and the setup costs. We have to absorb them or not. You see, there may be a situation, and this is one of the reasons that RMC has two pieces to it, where you don't have to do any setup costs. You might have a piece of your assembly facility just cordoned off or saved to handle certain certain products, simply because it's too costly and too much of a mess to deal with setting up and setting it down. And I'll give you a really good example. If you go to a car repair place, all right, and if they have a body shop, if they do repairs on the body as well as mechanical repairs, they're going to have that completely sequestered from the mechanical repair operation for a very simple reason. There's paint. They've got to have a specialized environment. They bake the thing, all of that. And so they just set that aside, and they absorb the holding cost of the materials there and the equipment. And then they have to charge a premium on that to get it back, which is one of the reasons why if you have a car wreck and you take your car, you'll be astounded by how much they want for a bumper or how much they want for this or that. And the simple reason is those are batch operations, and so they have to charge you a premium in order to pay for their holding costs, essentially. Well, that being said, we have these constraints, and notice they're binary, where they're a go or a no-go, okay? And then we have this second set of constraints where everything has got to be equal to or less than, and that's at G18 through G23. And of course, that's the left-hand and the right-hand side of the equation. So what we're trying to do is use the fewest amount of materials, okay, to produce the maximum amount of product and get the maximum profit. So we're maximizing there. So we have and we're assuming it's on, you know, it's a simplex LP type problem, linear programming. In other words, we assume that the profit is, and the costs are, you know, run along a y and an x axis. That's pretty much what we're looking at. So they give us the solution there, okay? And of course, if we wanted to, we could run the reports and get the reports to see. So I'm going to do that, and I'm just going to click solve. All right. And I should get, my reports, and I've got the answer report. I'll click OK. And let's look at answer report number 1. We have our solution. Now we have answer report number 1. And now in Excel, I like Excel better than what they do in the Lingo for a simple reason. I think they provide you a better picture. And here's the original value. And of course, we've already solved this, but we can look here. It's instructive for us to see original and final values, okay? And do we have anything that's different than we had before, okay? Here the final value, well, the tons produced of the fluid, we weren't going to produce any anyway. So we really, this doesn't tell us a lot. Of course, we've run this already so we can see. But here, when we come down to the constraints formula, this is the piece that's important, because what we're attacking with RMC is the classic problem of fixed and variable costs in terms of a holding cost. When you have, like I mentioned, the paint shop, you absorb a holding cost for having that paint facility there. You absorb the cost for having employees who can do it. Maybe they're cross-trained, and so you have some people that do some other things, and then when they've got a body to repair or paint to be done, they can, but that's probably not realistic. Versus the cost of not being able to service somebody who brings their car in, or not being able to perform that type of work, okay? If you want to be a comprehensive, say, auto collision center, and you'll see that many of these car dealers or insurance agencies, companies, will use a dedicated center simply because they can meld mechanical repair and the body repair together in the same place. This logic works it's just logic. That's really what it boils down to. So as you come down here and you look at the constraints, you can see the values, the formulas, and whether or not it's binding. And some of these are not binding, which means we've got a slack resource there. We can make a decision not to. As we come down here, we've got some slack resources there. Here again, it's not binding. This is binding. This isn't binding. So it's telling us what we can and cannot change in terms of tweaking this to get a little bit more maximum profit. And what this does, it typically, a graph will tell you a lot more than a table. In the event, when we deal with LP problems, it's typical that the table will tell you more than a graph, because what you see there, you can go and do the linear algebra, and you could find the feasible solution area, and you're going to look at it, and it's not going to make a lot of sense. I mean, it'll look fine, but you'll go, okay. But the table, that says something else in terms of what opportunities would I have or not have, okay? So this is RMC with the setup costs, and the mirror image of it is going to be RMC without the setup costs. So let's close this. As I said before, all right, you can upload either one or both of these. I don't care. All right. The main thing is that the main thing to get is this. Number one, a solver is an exceptionally, well, let me go to the beginning. Optimization as a mindset, as a way of thinking about decision making, is really light years ahead of how people typically make their decisions. Okay. They try to make decisions like this, but if they don't have that formalized process in their brain of the difference between problem solving and decision making, and understanding that optimization is 3 pieces. It's I maximize, I minimize, or I have a target value. and that I have to understand how the data are distributed in my industry, okay, it's a way of thinking, and that's really all there is to it. And then what are my constraints, okay, and what are the variables I want to change, and where do I go, and I go from there. So this works. That's why it's so versatile, is because it really is, in essence, about the best way to solve practical problems that we've found, okay? So you can upload this one. Now I'm not going to save this, and we'll go back here to, let's roll down here, we'll go next, and we'll find, well, let me see. I should have turned off my phone. I'm getting some kind of a notice. I'll go back down here to 7. Now we get that file. Module 6, excuse me. Now this is going to be RMC with the setup costs, and the text is going to discuss that piece. Okay, this is with the setup costs, and we talked earlier about without them. All right, so let's look at that. Well, you don't need to download it. You could really, if you're going to download and upload one of these anyway. Okay, so that's fine. I'm just going to show you the rendering, since they're rendering out for us over here. And again, you can see our profit per ton, the setup cost, the capacity, and away we go. And then I'll do the next one. And all right, and we'll scroll down here. We'll go next. Let me go. I'm going to back up for just a second here. And that's the setup. All right, and here I give you some information about the setup costs and binary approaches, and some more verbiage there for you to take a look at, and then the net profit, okay, and kind of an explanation. Now, let me go back here for just a second, okay, and here we go. We'll go to the module. Back down to 6. I apologize. I'm jumping around a little bit here. And you'll want to take a look again at both of these to see some of the differences between them. Now, let's talk just briefly about Martin Beck, okay? Because I want to spend some time this morning talking about where we are in the course, some of the stuff that we're going to be doing. And so let's open that up. Now, Martin Beck, okay, and I'll find that here in the chapter. And that starts over on page 332. Now, what they show us here is they have another, they have a variable, and we'll find out what those are, and a value for each of those, okay? And they have a production capacity constraint, and we're going to use 0, 1 variables. In other words, go, no go, use it, don't use it, all right? In this case, it might appear that the solution that we get is binary is binary in nature, but the truth is it's actually a continuous, the outcomes are continuous. Why? Well, I know this. If we wanted to, we could go and we could use linear algebra, and we could determine the feasible solution, okay, and graph it. But I also know this. I know that while those inputs are binary, I'm gonna go, it's a go or no go. I know this. The outcomes I get may or may not hit the maximum value, or could be subject to some type of random error or problem if what I've got here in terms of data that I input is either good or shaky or not so good. There's a continuum there. So if we look down and when we start to see the fixed cost model, right? And again, the usefulness of this tool, and I can't emphasize enough to you that it's a way of thinking, more than just using a particular piece of software. And notice what we were able to do. This is such a powerful method because it enables us to build a mathematical model and try it a few times before we ever do anything out in the real world or take any practical steps. And that's the beauty of this technique, is it lets us model. Now, once we've agreed upon what this model ought to be, this thing right here, okay, over here in the middle of page 332, what we're really looking at, or what we're starting to talk about is, okay, once I've identified that, could I build a prototype? If I can build a prototype of it, that's fine. A physical model, an iconic model, if you will, physical model. And then I could move to, well, let's call it a scaled model. And then I could move to a physical model and do testing with it to see what the thing looks like. And the textbook over in chapters 1 and 2 really walks you through that process of how we work through a mathematical model and then translate it out to reality. Okay? And that's very typical for just about any type of product, any type of service that we use. So again, it's a way of thinking and saying, what are my resources? What am I trying to do? Am I trying to maximize, minimize? Do I have a target value I want to hit, etc.? And you say, this sounds like the same thing every week you tell us. And yes, I am. I'm going to tell you and keep telling you until the end of the course. And then hopefully when you're out there in the world, you'll look at problems and attack them in this way. This often can keep you from making some blunderous decisions where you may have bad data, or you may not have identified the correct variables. The ability to, especially with Solver or any of these products, but certainly with Solver, the ability to develop, to run a simulation using random numbers is exceptionally powerful. And I can't tell you how important that is, because what it lets you do is run different models of what the thing might look like. And as you start to, and just using the law of large numbers, you're going to start to expand your understanding of the universe that's there, or the possible outcomes. And the better you can do that, the more prepared you're going to be to deal with the risk that's inherent in that operation. We go through capital budgeting exercises. We go through these types of exercises to manage risk and to manage uncertainty. And while we're at it, there's a book I want to recommend to you that I think you should read, that will be as important as any textbook you may ever read when you're going to business school. And I want to show you over here at Amazon the name of the book. Get this up here. And there it is, Against the Gods. This is a fantastic book, and the remarkable story of risk. And what Bernstein, who is the author of this book, does is he walks us through the process of how people departed from just pure superstitious belief to understanding risk, understanding potential outcomes, contingencies, and how that over time, over roughly the past 1,000 or so years, that's kind of evolved to where we are today, where we use risk, where we attempt to manage uncertainty and risk all the time. Okay, I'm taking a course right now on a new emerging area in finance. It's called FinTech, and I'm taking the second course, and it deals with the regulatory issues in FinTech. And it's interesting because the lecturer, the guy who's the faculty member for the course, the instructor, he was talking about the financial financial meltdown in 2000, 2008. And he was talking about the primary cause of it was they took a lot of bad, what they called, these were securities that were sold that were collateralized, or in other words, they were underwritten by tranches or sets of mortgages. And when the mortgages went bad, then the securities went bad and all kinds of things happened. But the whole idea was this belief that we could manage risk. And if you've taken your finance course and you've done a weighted portfolio, this is one of the ways we try to manage risk. And this is an excellent book because it shows you the evolution of that thinking, where we're as in any enterprise, we're concerned about managing uncertainty to the extent we can, or risk. So that's pretty much what's going on here when we look at this, when we go through management science, and when I say, okay, I can simulate all these data and I have the tools to do it, so I can see what that world might look like given changes in certain variables. All righty, now again, it's the same story with the Martin Becker. Any one of these cases that we look at, okay, but I really encourage you to get that book and read it. I think it's a great one. I probably one of these days will include it in the management science course because I think it's important you get that. So one of the things that occurs is when we make you take statistics, it's my fear that you take statistics and it's taught to you as just a bunch of mumbo jumbo math and learning how to do learning equations and not understanding that at the bottom of statistics is really nothing more than probability theory. That's really all it is. The reason that I compute measures of central tendency, a fancy way of saying the mean, the median, okay, are because I want to see how much stuff is alike. The reason I look at measures of dispersion, like the standard deviation, the range, is so I can see how things are dispersed, how much they're different. And I'm always looking for the stuff that goes bump in the night, and the term you'll hear people use is an outlier. I'm always looking for outliers. What is the outlier here that could really create some havoc for me? Okay, so the Martin Beck, you have it as well. And we'll take a look just real quickly at that. This is a linear program, and this is the transshipment problem, if I'm not mistaken. Yeah, they've got these proposed plants, an annual fixed costs, and then an annual capacity. Then they have distribution centers. And it's, again, it's that distribution problem. And I think I might have talked about this some on Monday, if I'm not mistaken. But again, this is one of these network problems, and you can see when we talk about what we call the node, it's that circular thing there, like Detroit. It's a destination or an origin point. It may be both. Then we have the arcs, and those are the lines from each node, and you can see the plants. If you take a look at the far left corner, the capacities, then the distribution routes and the cost per unit, and then the demand. That is the distribution centers, okay? So they're trying to work with this problem, and you'll see they want to get that handled as efficiently as they can. And so finally down here over at page 335, you see, and if you anticipated that this is probably a minimization problem, you're right. Simply because we're trying to minimize costs. All right. Now, again, we see the old familiar friend, the objective function with its constraints. And there we go. And then we get the Martin Beck solution. And this is using that lingo tool that's over there in the publisher. and we see the constraints, and we look for any slack or surplus. And we don't have any slack or surplus here. This is a pretty tightly constricted problem, a pretty tightly constricted network. So we don't have any slack or surplus variables there, so we say okay. Now, you know, I'd mentioned earlier, we had talked some about these network problems, and especially the arcs that are involved. The arc is the biggest issue because it's the root, okay? And as the crow flies is not the same as how your car gets there. And as I've said before, when you think about these big companies, when you think about an Amazon or you think about UPS or FedEx and what they can do, it's miraculous. The amount of packages they handle, their ability to get them distributed properly into your door is just a marvelous feat. They're just incredible. And really the driver in many ways of the global economy. Now, you'll see here, for example, now I didn't include this. This is a bank location problem. But here you can see very pretty typical. They've got this county region, all right? And so they're trying to figure out, all right, where are we going to put branches of our bank? Now, unfortunately for these people, there's a tsunami coming. And the tsunami it's already started. The tsunami is called virtual banking. And the tsunami is, and the way that you know, a tsunami has two events. Three, there's an earthquake typically, okay? And then two, the water recedes backwards and then it comes forward. And it's the same for these banking facilities. If you could, many of you probably already do your banking on your phone, or you pay for things on your phone, maybe use near field communications. The network issues at that point will be really more about telephone networks and cell phone networks than it will be about physical networks. Now, there are always going to be people that have to go to a place and have a teller, but it's going to become fewer and fewer and fewer between. For the simple reason, it's cheaper for them to put an app on your phone and have you do the transactions on your phone, or say do banking online. And you could, if you don't have you could do things today like you could take a check, you can scan it, it's in your account immediately. We're seeing these things where we have people-to-people payments. So I can pay somebody automatically. I can deposit money in their checking account. I don't know what their checking account is. I just have an app. I identify them as a friend or an end user, whatever. Boom, I send it and back. PayPal is the forerunner of a lot of this, as has been Rocket Loans and people like that. And you're seeing more and more the physical technologies, the near field communications, where I just walk in to Walmart and I have my groceries and Walmart deducts all the money and does my bill. That's reality, but it so spooked people that they're kind of holding back on it. And there are a lot of people who don't want to bank by a phone app. I'm one of those. I do online banking, but I do it on my computer. I don't know what it is about a phone. I just don't like it. It doesn't feel comfortable. It doesn't feel safe. Although it might be safer than doing it on my PC. Well, all that being said, I think you can see as we've worked through this, we've got a whole versatile set of a fairly diverse set of problems, though. They deal with capital budgeting in different circumstances in capital budgeting. And you can see that in Martin Beck, again, we had a solution. But again, I want to emphasize to you, if we had a management science this is an intro course. If we had a management science 2, we'd be doing a lot of work running. We'd be doing a tremendous amount of work running simulated data to see what it looks like. And we'll do a little simulation here later in the course, and you'll start to go, oh, okay. And you say, well, gosh, that's kind of geeky. It's a lot of trouble. Let me say this. I'll tell you what trouble is when you and your team put together a capital budget, and you really didn't take into account, or you didn't say this has got some real potential for variation, we can have some real problems here, and you didn't tell somebody that, you didn't warn them of that, and things go bump in the night and it flies apart on you, and suddenly you're sitting there wishing you had told them, here are the risks involved, here's what it looks like it could be, a range of possible outcomes, and away we go. All right, so there's a lot to be said, but we don't have time for that, and we won't do it. It's a shame. I wish we could, because I think most of you would find it very, very fascinating as you can start to try to mimic. We do a little bit of mimicking of the real world, but taking a model then and using random variables takes that model and makes it live. Well, let's talk some more about where we are in the course and what's going on. And again, let me pop in here and see all we've got here. Okay. All right, Isaiah, good to see you. John Kent, Michael, Noah, Patty, Robert, Sarah, Shane, Jared. Let me stop before I go into some of the course stuff that I'm going to talk about. Anybody have a question I could try to help you with? Okay, well, if it should occur to you, you can always send me, you can hit the chat, which would be fine, or you can certainly send me an email if you choose to do that as well. Okay, now let's scroll down. And again, I think I have a whole Friday, and you can just simply upload this stuff and you're in good shape, okay? And I did that for a purpose. I didn't ask you to go and manipulate any variables or anything, because I wanted you to go and take a look at the cases, get a feeling for them, and see how we've used these binary go, no-go models in terms of working with these capital projects. I've got a whole set of information here for you to look at in terms of capital budgeting, and capital budgeting basics, and order and setup costs. Some things that you may not have encountered in some other courses, and certainly the Northwest Corner method, which is a model for just about all types of network problems, and then some information about jobs and logistics. Let's come down here to Module 7, which is next week, and you'll notice that you've got assignments that are due on the 12th, and the 12th is a Friday, as I think you can see, at 5 p.m. Now you say, why are you doing this? Is it because you're lazy and you don't want to teach? No, that has nothing to do with it. If you run out of material, that will never happen. Why? Well, let's look at this. I want you to start to work, okay? And this is some flex time, okay? These are what I consider midterm exams. Although I don't weight them as such, I consider these 4 chapters as really like together form a midterm exam for all intents and purposes. Okay, not comprehensive, but a chunk of material that covers almost virtually into, I think, 1 or 2 sections of the textbook. Just to confirm that, let me go back over here to Vital Source for a second, and I'll go to the contents. And we'll find in the book, it put them into a series of sections. And we'll see here, 7 is integer linear programming. Then we see nonlinear programs. So we looked at, chapter 7 deals with integer linear programming. And then those that are nonlinear, where we'll start to begin to work with the non-linear piece of solver and or the evolution, the GRG nonlinear, and I'll explain what that's about when we get there, and then what we call evolutionary models, and then project scheduling, PERT CPM, okay, and those types, and then 10 inventory models. So we've got, what we have here are these cases are the they're all kind of network problems of one sort or the other, and so I've thrown them all in together. Then we'll move into the waiting line models as we get to chapter 11. But I saw that as a cluster or set of chapters. I thought, okay, this will make a good way for us to use this as a midterm. Okay, so that's that whole that week. Those one, I see I've got 1, 2, 3, 4 exams for you. They're all due by Friday. Now, that being said, because of the change in the schedule the university's made, we kind of had a problem, but an opportunity. As you know, the university has added in 2 days. All right, so we have the full week for Thanksgiving. We have that off, which I'm okay with that. And we'll go down here and we'll find Thanksgiving week. And here it is. The good news is we don't have class. The bad news is it's on the back end of the semester. And what that means, if we don't do a little front loading, then things get dicey really, really quick in terms of material that we cover, etc. So I'm giving you next week as slack time, all right, to begin to work on your finals and to begin to work on and to begin to work on your I've got some projects there for you, okay? Now, you say projects due Module 15. Let's go down to Module 15, take a look at them. Now, some of you will be wise and you'll work. So you'll do the exams, but you'll start to get a feel or at least come over and explore these projects. Some of you will blow it off. You'll just do the exams. And then when it's time to do the projects, you're going to be scrambling. So you've had a management science course. You're about halfway through it. I hope it will be the former and not the latter. But nonetheless, here we are. These are projects. And I've got the instructions. And you're going to get a chance to use SAP, okay? And then you're going to do some work with the Anderson text, and we'll be getting into that. And that's the Anderson text in this course. Let me go back over to Vital Source real quick. I'll show you. I'll go over to home, to library, and here it is. That's the Data Smart. You say, what are we going to do with that? Oh, this text in the Data Smart. We're going to do some work with some unstructured data. And we're going to see how we can use Excel functions to work with some unstructured data and make some sense of them. And we're going to do one of the neat things we're going to do. And this guy he's the CIO of MailChimp, okay, an email service. And one of the cool things we're going to do is we're going to build and test a model for filtering spam. We're going to see some other uses of this tool, like identifying a market segment. So this text really adds to the course and gets us involved, gets us working with some advanced techniques, but they're not all that terribly hard to master, but also in some great uses of Excel. So that's where we're going to be heading. So that one's going to be a pretty easy one. That we worked with that before, okay, and it's self-developed quiz. I've just got the instructions there, what you want to do. The SAP, I've got part A and part B, the instructions for each of them, and they're there for you to see. They're all written out, and so I want you at least to start to get a feel for them, okay, and what and what to do with them. So those are some key projects you're going to do, and then as you would guess. All right, there's no class time, so I'm giving you 2 weeks basically here. 1 week to kind of get started on it, the second week to get it finalized, get it done and turned in. Now, as you can see then, the last week, of course, are the finals. And you say, well, could I use this flex time, both of these 2 weeks of flex time or any flex time to work on finals and on these projects? Of course you can. Just make sure that you stay on top of any regular work that I provide for you have you to do. Okay. Well, I'll tell you what, it's 11:47 and we started about, I think, 6 or 7 minutes early. And I think we're just about ready to wrap this up. Now, does anybody have a question I could try to answer for you? Anybody? Okay, if you don't, or something should occur to you, please feel free, shoot me an email. And it's Wednesday. And as I had mentioned, in my weekly schedule, which I send out to everybody, it's in each class and my advisees get them. I'm doing the broadcast from my office. So I'm here in Shawnee. I'm here at my office all day today in the afternoon. And so I don't anticipate having to leave to go anywhere until I get ready to go home. So I'll do a screencast at 2 o'clock. Now I have one other, I forgot to mention this, at noon. Okay, this is one of the reasons I'm rushing myself through this. I've got to go and do a class observation of a colleague. So I'm going to finish this off, go down, do the observation. I come back up probably about 1 o'clock. And then I have a 2 o'clock. So between 1 and 2, I'm available. And then after 3:15, I'm here till I leave. So if you need to stop by, please feel free. Okay? That's the story, folks. Thank you so much. And I'll stop the share and we'll go from there.